Day 18, and we've got some 3D modeling. So essentially, we've got a list of 3D coordinates, X, Y, Z, Z, I suppose. And we want to work out how many sides are exposed if we sort of had a shape which was made out of these boxes. And we've got an example here which is 64. So let me just show you. We'll sort of get into this through thinking about the 3D. So here we've got some boxes, thanks to the Excalibur box person, whoever that is. And we've got, let's imagine these points are sort of 0, 0, 0, 0, 1, 0, or rather 1, 1, 1, etc. I mean, you get the fact there are coordinates. I get confused with coordinate systems. Anyway, so these coordinates that we had here, these represent places for the boxes to be. And so our job is to work out how many faces are visible, or at least not necessarily visible, but don't have another shape directly against them. So in this case, we would count this square would have, so this square, let me put this here. This square would have 1, 2, 3, and these sides would be covered. This square would have 1 on the back, so 1, 2, 3, 4, 5, and this one is covered. This one also has 5 because this side is covered, and this one also has 5 because this side is covered, which means that we've got a total of 15, 18. Easy. Put together a bit of a coordinate system here. I don't know. I'm going to try and keep to it. I don't think it matters that much, but yeah, I think I probably should have just gone up rather than down. In any case, the way we can do this is by going through each face and looking at the space to the right of it, to the left of it, up, down, forward, back, and then seeing if there's any boxes in that space. And we don't need to worry about kind of modeling a 3-dimensional array or anything like that, because I hate doing that. So we'll be using a set of coordinates, which makes it much easier, at least for step 1. So this one looks, I'm going to now say, deceptively simple. We just need to go through each box, go through each 6 faces that it has, calculate kind of forward, back, front, up, down, left, right, and then check whether those coordinates are in the set of boxes that we have, and then sum them up. And I've done this manually, and it works. It appears to work anyway. And so I've got my state planned out. I've got my box class planned out as well. And so I'm basically just going to go straight for it. But I will show you first the trial data just sort of plotted out in case you're interested, and also my real data plotted out. I used a program called Goxel, which is wonderful, but slightly buggy on Macs. So for instance, you have about a 2-second timer to open any file. If you leave the file open dialog open longer than that, the application will crash, which keeps things exciting. But in any case, I managed to export from it and put it into some sort of slightly sort of weird VS Code visualizer, which I might not actually show you now I think of it. Just give me 1 second. So this is the sample data, and we can kind of use this program Goxel to zoom in and take a closer look at it. If I can remember how to use it. 3D is really challenging in a virtual environment, turns out. So you can see it. It kind of it looks like a little kind of dumbbell almost, and so we can see it from all these sides, and it all looks nice. Now, the interesting part, thing that makes it kind of interesting, is there are some gaps in the middle, which if I can manage to position myself in the right place, I can possibly try to get at. Okay, I'm not getting anything there. Let's see if I can do this. Let me actually, you know what I'll do? I'll use this thing. There we go. Yeah, so we can now take a look in here, I think. We could if it would work. Now, why is that not working? Okay, I got it working. So yeah, we can zoom into this. Let's take a look here. And we can see a bunch of stuff about it. But the interesting thing, let me just, yeah, here we go. The interesting thing is that there's gaps. So if I get rid of these two, you'll see there's a gap in there. Just try and get rid of one. Yeah. So you'll see there's a gap in there. And these count, these inside ones count. We need to be counting those. However, here, there's no gap. It's full. And so those don't count. So this is a kind of useful input in helping us to catch that particular problem. I'll also show you my real input. So this is the real input. This is my actual input. Now let me see if I can switch to something which doesn't. Yeah, okay. So we can rotate this around. You can see it's a big kind of sphere. And well, you know, it looks pretty nice. If we zoom in, we can see that there's an inside to it. And so we're going to need to count these inside points as well. So it's kind of hollow sphere, which is cool. I've also, when it comes to the first one, the trial data, I also exported some of these slices of it, and you can see that the slice of it here indicate that there's a gap in the middle, and the slices of the sphere look like this. So you can see it, let's say we're starting at the top, I don't know if it's top or bottom. You can see it kind of almost like a MRI or something. So we've got this to handle. Now let me shift over to VS Code. Okay, and we're pretty much good to go. I think unless I've made some really hideous mistakes, this shouldn't be so challenging to get done in a decent amount of time. I don't know why I keep torturing myself by saying this, but it is true. That is what I think at the moment. So let's get started. Okay. I'm going to start off with actually from utility main import show. Yeah. Okay, so for box, we want to have a chord, which is that's going to be a tuple, 3 integers. Face is visible is going to be an int, and it's going to start off at 1, and we're going to have a neighbors which we might extract from here anyway at some point. I'm also going to just go ahead and get state skeletoned out as well. That's going to be a set of triples. It's going to be a box. I think, yeah, it'd be convenient to have that. And then I'm going to have a populate occupied. A is occupied. A total face is visible. No viz as well, just in case I need it, which I probably will. And yeah, this gets us to that skeletoned everything out. So to get the neighbors, we're going to want chord 0 template off of this. That's 6. That's the right number. So +1, -1, +1, -1, and +1, and -1. Great. Okay, so that's the neighbors. Now to populate the occupied, we're going to essentially go through and then we're going to get its coordinate out and add it to a set. So let's have this be default. Okay, and we're going to right. So that should get us all the coordinates in there. Then this should be a matter of chord in self-occupied. This should be a matter of return sum of this and then this. Let's do something here. Okay. Fine. Okay. Now my next bit is to load boxes state. And I'm going to start running this. Okay. There's probably a way to do that. Do that. Oh, I'm just making it too complicated. Okay, items 0, items 1, items 2. Okay. Oh yeah, it's got to be a box. Very silly. Great. Okay. Now we're getting all of them. 235, 222. Okay, great. Nice. All right, next bit. Calculate total faces visible. Okay. Or really we should call this populate, and this total face is visible. There we go. Okay. State box, index, int. Okay. Okay, so for this box, $78. That's the wrong answer. Hmm. So we're definitely not counting sum. Now, how could this be wrong? Oh no, this is visible. Okay, so are there any invisible faces here? Oh, I know what I've done. I've forgotten to populate the, yeah, here we go. Yeah, great. Okay, 64. That's the right answer. Perfect. So let's change that to be the real. 3432. Just off a platinum there, but fine. 3432. Let's try it. Okay, great. So that's part one done. Okay, something seems off about, this is the bit where they totally ruin our lives. Something seems off about your calculation. Cooling rate depends on the exterior surface area, but your calculation also included the interior the surface area of air pockets trapped in the lava droplet. Instead, consider only cube size that could be reached by the water and steam as the lava droplet tumbles into the ground. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet, 225, so the exterior surface area of the lava droplet is 58. Okay, so kind of the obvious part 2, I suppose. So we've got a little bit of a job to do here. We need to work out now which are the interiors and exclude those, I suppose. I'll give this a think. So let's say we could pick a cell that we know is on the outside. Like we've got a face that we know is on the outside. Shouldn't be so challenging, I think. Maybe the top one, the one with the highest Y, or Z rather. So at that point, we could then consider the top face. So let's say, it'd be nice to color these in, wouldn't it? Let's say that we let's draw this out. I recently learned this feature. Let's put this in a color. So let's say that, oh gosh. And I didn't actually want that. I didn't want the stroke. I just want the face. There we go. So let's say we start here. And then if we could somehow work out what the faces that would be adjacent to it would be. So we could tell this for an individual cube, right? That would be quite straightforward. We could know that, oh gosh, that's not what I want. So we could know that a cube's faces network interlace in a certain way. So this, let's call this top. The top is always related to the in fact, we'd best come up with some names for these possibly. Let's call this good if I could do this, wouldn't it? Let's call this, all right, fine. You don't want to do this? You don't want to work? Okay. One moment, let me give this a refresh. It's asking me if I'm sure I want to refresh, and I definitely am. Okay. Yeah, so let's call this, oh, they're transparent, that's why. Let's get rid of this. Okay, let's call this left, right, up, down, back, and front. So we know that the up is connected to the front, and we also know that it's connected to the left as well. So let's just kind of mark this out as something we're paying attention to. I think I might mark it out slightly differently. Let's mark it out like that. Okay. this, and this. We know these are connected, and we also know that really there's only one face that it's not connected to. So it's connected to this, and it's also connected to this. Oh, but it's not connected to the bottom one. So that's fine. We've got a sort of net, I suppose, we can use here. And that's an interesting idea. Let me write that down. And so we know that if there is a square to the right, then we also know that we can say that it can also transfer to the top of the right one. It can no longer transfer to the right of itself. We know that if it's got one to the back, it can transfer to the top of the back. If there's one to the left, it could transfer, but there's not, so it's going to go down. So we can say that each direction, each of the four ordinal directions, is that right? I'm making up words now. So each north, east, south, and west, they can either go, if there's a cube to the back, it can go north to that cube's top. Otherwise, it can go down to its own kind of back side. If there's one to the right, it can skew along the top. Otherwise, it can go down. And then, so we've got that logic. And so if we repeated that logic across the whole sphere, presumably we would end up with the right number of faces that we're showing. So that could work. I'm just working out if we can unfold this to a net, and so I suppose that's kind of what we're doing. Let me try and write this down. So for each, I don't think I want this to be red actually. For each box, if there is a cell to the north, to the back, color the top back of that cell. Otherwise, color the back side of this box. If there is a neighbor to the left, color the top of the neighbor. Otherwise, color the left side of this box. And I'm kind of realizing this needs to be generalized to all faces as well. And so on. And so if we were on the left side, it would be the left side of the other cubes that I'd be thinking about. And I'd need to be thinking about my own. So we sort of need a dictionary from base to side. Okay. And then if we just keep track of all of the ones that are sort of newly colored, So we kind of add to a queue all the ones that have been colored. And then if there's no if there's no where for it to go, it just stops. It's been processed. So we could keep a queue of every cell, every side. Yeah, so that would work, right? And wouldn't be so inefficient, I think. It's kind of quite possible. Let me try it with the trial. Sort of figure it out with the trial input. Okay, this may take a while for me to open this file. Okay, so I've opened up, after much hassle, this mesh lab thing, which thank you for making it, whoever you made it. I find it a little bit tough to use, but I'm going to go through and kind of apply the logic that I've just come up with to paint across this mesh and see whether we get everything. So I'm going to just get a little notepad here so I can keep track of some numbers as well. Okay. So we're going to start off with the top face, which is going to be, the top one here. So actually, what am I looking for here? This one. Yeah. And so I'm going to start off with this one. I'm going to select this and I'm going to make it this nice pink color. So that's one. And now, okay, let me look to the left. And I'm going to see this face, this face here, which I will color in. I think when I'm done with them, I'll color them in a different color. So I'm going to say these ones are still kind of active. Okay, so I'm going to color in this one as well. And I'm going to color in, just going to sort of go down here, color in. So because there's a cell kind of down, then we'll go sort of across here. Then I'm going to be using this one, and then it's kind of pretty clear that I'm going to color in all of these. Okay, that's brilliant. Just reset them all, why don't you? Yeah, okay. I hate this piece of software. You get the idea. We're gonna go through. It's probably going to work. It's better than getting this thing to work. I don't understand why it continues not to work. Is that why? Anyway, okay, fine. Well, let's keep going then. So okay. This one, then this one, and this one. And this one, sorry, this one and this one. So this is what will happen if we go kind of recursively, I suppose. We'll need to end up going round all the way here, here. We'll end up going fine. Yeah, great. Okay. And also this one. That's not what I want. That's not the one I want. Okay. Let's try this. This will end up going all the way around here as well. Okay. And so at that point, we end up with all these colored in. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I think that's 22, which will kind of make sense because we've got 1, 2, 3, 4, 5 on here. 1, 2, 3, 4, 5 here. And then here we've got 1, 2, 3, 4, 5, 6. And it'll be the same on the other side. 1, 2, 3, 4, 5, 6. So 2 5s and 2 6s makes 22, right? 22, great. Nice. So that's 22. Now, if I do the same thing here, I will get, let me try and not ruin my life by doing this the horrible way again. All those, great. Okay, so that's all of those. Now we can get these. This is so fiddly to work with as well. Okay. No, not. Is that right? Yeah, that's fine. Fine. Where are we up to? Okay, great. And also these. Oh, we're gonna have to rotate again. Okay. Now, what have we got here now? So we've been around this way. And we've been around this way, apart from this little face here. Okay. So we've been here, and we've got, so as a result, we will have had another 20 on top of this because we've already done the ends. So that would be 20. And that makes sense because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the other side, great. And so the only bits left to do are these 4 here. Are these more than 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16. And these we would get kind of by backtracking. So we'd need to not cover any cells we'd already colored. Okay, so that gets us in the end 22 plus 20 plus 16, which is 58. Is that the right number or not? $58, yes. That is the right number. Okay. I am so sick of this software. I'm going to close it. Also, thank you for the open source authors who made it. Value your work. I'm new to it, so I'm not used to it. Okay. So having done that, have we learned anything useful? So overall, we're going to have to, starting with the top Y cell, or it's like create a queue with the top face of the top Y cell. Then get neighbor faces, which we can use this algorithm for here. If they aren't already colored in, add them to the queue. A lot of problems have ended up looking like this. Add them to the queue, and then, well, color them in, I suppose. Add them to the queue. And that's it, really. And then at the end, we total up the number of faces colored in. So we're going to have to do a bit of extra work. This sort of horrible algorithm here is going to be, I can already tell that I'm going to run into some trouble with it. So let's try and squirrel this out a little bit. So to get neighbor faces, we're going to, so we have our starting face. and a cube. We want to take we want to somehow get what are the neighboring faces. So for direction in north, so these are going to be it's going to be a rotational problem I'm going to have to puzzle through. North east, I think it's going to have to be northeast southwest. We're going to say that translate direction to translate face and direction to coordinate and face. Then if has a cube in it, add cube face. Otherwise, add cube new face to neighbors. Okay, so we're kind of we've got to keep track of cubes and faces. So for so let's talk. Let's have face Q in cube 1 here and try and work it out. So so we're going to go through. We're going to first go north. Okay, so to translate north, no, wait, Q north to oh gosh. To if we are at 1, 1, -1, we want to be at 1, 1, 0. And the new face would be actually, we gave this a name, didn't we? Let's call this front. And let's call this 1, 1, -1. Front, north, to that. And then we check that coordinate. Does it have a cube? No. Otherwise, we add cube. Okay, so the tricky bit is going from front north which actually we can probably model this as kind of one as a change, and then we can add it to the current coordinate of the cube. So in which case we want to end up with a dictionary essentially from probably front, north, east, south, west, and this one's going to be up, up, right, left, no, down, left. So that's for the front. For the right, it would be, this is going to be very dull. I'm not going to make you watch this. I'll do this. I'll pause this. So I'm about to go out and I'm going to see how much I can get done before I take my planning break, which will involve me going to the bar. In any case, I more or less decided all of this was nonsense and we could just model faces as just the same as coordinates. So that would be quite easy. So I've really got quite a small amount to do after all that palaver. Load up the boxes, set up a queue with the top box's face in it. While the queue has any in it, take the first one out. And for every neighbor of neighbor face, if that cell is occupied, otherwise then color in the adjacent face. Otherwise, add the current face to the neighbor box and make that colored. And then I think we're pretty much done. So just need to, sum up all the faces colored, and then we'll be fine. Let's see how it actually goes. Okay, this is still running. Actually, let me just do some window management here. Let's bring that out here, put this here. Okay. All right, and we will shift this into part 2. Oh gosh, that's part 1 again. Oh, it's opened here for some reason. Okay, fine. Okay, part 2. Let's get started. I'm definitely going to stop at 10 past, so we'll see how it goes. Okay, so I don't want this anymore. Yeah, I don't need this, and I don't need this. And I'm going to go with the trial again. Okay, so first thing is to implement the box faces stuff. So let's go and do that, which is going to be faces touched will be a set of okay, and this will be initially and the face neighbors is the same as the neighbors, but filtered out 2 things. It's not our own coordinate, and it's not the reverse of our own coordinate. which I don't know. I mean, it'd be pretty cool if Python was clever enough to do that, but I don't think it is. It is not. No, nowhere near. So we're going to be doing this and then that. Okay. So this, I think, will, if I was to create a temp box, like this, then actually I made a slight error here, but it's not a big deal. Yeah, so we've got 5, 3, 2. Yeah, so actually it's sort of this vibe. Yeah, and so if we were at the face, then we want to pass this in as, let's say we're at this place. And so we want all the ones apart from the opposite and the current. So it should have 4. Yep, that's great. And then we've just got to have, we want to kind of, I think we made an add yesterday, right? Yeah. So we can use, we'll be able to use this. Okay, so we'll need that later. Great. So that's that bit done. Now we want to get the main loop, which will be want to populate the occupied. Q should be get top box face, which will be, we need the state as well. probably a better way of doing that. Now I think of it. Okay. This will that. Yeah. There we go. That's what was wrong there. Okay. It doesn't really matter which one we go from the end of, so whatever. We could pop from the start. That would be fine. Or we could pop from it. Doesn't really matter. Okay. All neighbor face in box. Neighbors. Anyway, we should get if state is occupied, add C scored base. Then and the box. No, if it's occupied, then so I got that wrong. If it's occupied, then we add the current face of the neighbor box. Which is this. Right. Otherwise, we append the current box's neighbor, face neighbor. That's right. Yeah, great. So this is the face neighbor logic in here. We don't care about the current face. We've used that face already. Here. Okay, so for this, we want to go through the state boxes. Let's get a maximum Z. And the maximum Z will then need to have a face which is this, because it'll be the outer edge. Data types getting a little dubious here, aren't they? Yeah, okay. Fine. I could probably clean this up, but I'm not going to do it. Okay. right? And then when we're done with all that, we can sum up. Oh yeah, we actually need to mark the faces. Yeah, so we want to go to the box and faces touched, add the face. Great, okay. And then the total should be the sum of box faces touched for box in state boxes. Or the length of that, I suppose. The length of a set, yeah, fine. That's fine. Okay, I don't know if this will work, but if not, then we're going on the planning break anyway. Oh, am I running the right thing here? I'm just looping forever, that's why. That's my problem. Okay, so we need to so if neighbor box face is touched, face right, and then if face neighbor, okay. Okay. 6. Well, that's no good, is it? It's not going to work. It's definitely not 6. That's one thing I'm sure of. Might be time for my pause to go out. Definitely. All right. See you later. So in my planning break, I had a thought. I don't know exactly why my program's going wrong at the moment, but I am sure that there's a mistake, or probably an unrelated mistake to the problem that's currently causing it to return 6, which is the faces of a of a cube rather than what it should do. So let's take a look at this and imagine that we've got this sort of a situation here. So imagine we've got this, and we are currently on this cell, and there's no cell in this spot here, so we should go down and color this cell, and then well, we sort of get to the interesting part here. So let's say this happens, and if we just rotate this, we'll see another view on it. It doesn't really matter, but you'll note here that we've checked if there's a cell here, and because there is, our current algorithm is going to go and cover this surface of this cell. What it should do is it should go up here instead. So that's problematic. What we need to do now is to check if we've got a cell like this, we need to check, of course, we need to check this spot to see if there's anything here, but we first need to check this spot to see if there's anything here. And I think I know a way we can do this, which is to translate this cell here by the face vector. So we've got 0, 0, -1. If we translate this by 0, 0, -1, we get this position. If there's anything here, we instead need to go to this face here. Now, the only problem that I'm still figuring out is how do we work out what face this is? Because clearly we don't want to just go on the top, right? So we want to go on this face. And so if this face, let's say, is 0, 0, -1, then this face is going to be, let's say, the left face. It's going to be this one. If it's on the other side, then it'll be, actually, that's not quite right. This is going to be, it's going to be +1, and this one's going to be -1. Yeah, that's right. So we kind of need to know, and I guess in a sense, so this cell, by the way, is 1, 1, 1, 0, 0. From this cell's perspective, I suppose. So this kind of seems to help. If we've got this, if we're going this way, well, then we can look at this. Well, actually, it's the opposite. It's the opposite. No, I was right the first time. This is the left face, and this is the right face. So it's the opposite of what it should be. So it's the opposite of. But that makes sense, because if we're going this way, the face will be looking this way. So we want to multiply that by -1. So now our algorithm should look like this. Okay, so let's say we're at face 0, 0, -1. We get the neighbor faces, which are 1, 0, 0, -1, 0, 0, 0, 1, 0, and 0, -1, 0. We check neighbor face plus face, which would be, let's say we take the first one here. It would be 1, 0, 0 plus 0, 0, -0, 0, -1 to make 1, 0, -1. And so if this cell here, it's an absolute nightmare. If this cell here is 0, 0, 0, and this cell then itself is going to be so it's to the right. So let's say it's to the x. So it's this one, and then we go up 1 to get this. Yeah, so that's right. So we check the neighbor face plus the face. If it is, we color in neighbor face times -1 on neighbor. I think. Yeah, that's right. We check, then we check the neighbor face has a it's really this. Then we check the net cell plus the neighbor face. If it is there, if it is, we color in face on neighbor. Otherwise, we color in neighbor face on ourselves. Simple, right? No, not at all. I'm probably going to get it wrong several times. So we're going to need to like visualize this out as well. And I think what I'm going to try and do is like visualize out left, right, up, from the top, from left, from right. Oh gosh. How am I going to visualize this out? I could render it in 3D, but I'd have to draw the vertices and all the sides rather. That would be an absolute hassle. Yeah, I'm not gonna. I don't think I'm gonna do it. I think I might just have to do the horrible debugging bit. Yeah. So okay. So that's one problem. The other problem is why we're getting 6 here. So we're getting 6. We're starting. I want to actually print some stuff out, figure out where we're starting. So we're starting off at 226, which is I'm just sort of loading this up in my gosh. Okay. Down, 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 down. Okay. So it's at 226. So 6 is so 6 is the top, which if we're going from, I suppose it doesn't really matter which way. I'm getting the z-axis kind of confused, I think. It's probably the furthest one down, but it doesn't really matter. So we start off at 226 and we're at the top face, so that's good. Okay. We just, all right. Then we add in, we should be adding in 4 more sides. I'm going to actually print that out as well. Okay, so we get 4, which is 226, 226. I'm actually going to, okay, let me just do this. 226. No, this is incorrigible. Draw this across. Great. Okay, then we're getting 226, the four sides, which is the X. So left, right, forward, front, back. Okay, so that's good. Now we're pulling out. Let me actually see what we're pulling out. Yeah. Okay. So pulling out this one. Oh no, actually, let me oh dear. Okay, so that's the active one. Great. Now we're getting the four out. But yeah, so we get this one out. Now when we're on the we should here, according to the current logic, we should go to another cell. We should go to 2, 2, 5. But we're not. We're going to even more of 2, 2, 6. Do we actually get any other cells? Or is it just 2, 2, 6 forever? No, we don't actually move to any other cells. Okay, so let's see. Yeah, we never get there. Now, do we get to this point? No, we don't. Now, why isn't this being activated? So what's the neighbor coordinate? Okay, so for every face neighbor, which is going to be okay, yeah. So we check that and we don't get anything. Now this one, we should check 1, 2, 6. Okay, so 1, 2, 2, 5 should definitely be in there, right? 2, 2, 5. Oh no, actually it's not. Oh yeah, we're so 2, 2, 5 is the gap, right? So that shouldn't even be 2, 2, 5 is the gap, and it's trying to go down. So that kind of makes sense. So 2, 2, 7 will have nothing. 2, 2, 2, 2, 5 doesn't have it. Oh, okay. Right. Because it's not right. Okay, that makes sense. Because there's no, because it can't go up. Let me show you this. Because it can't go up. Let me just show you this. So the problem is, I think, that this has nothing to move on to because we're not going to any of these diagonally right cells because of this gap underneath. See, because it can't go to these cells, so it's just getting all of its own faces. So that's a good sign. That shows maybe I've only got one bug. That's good. Okay, well, I mean, we can hope, right? We can hope. Okay, so let me get rid of all these prints then. But I'll probably still keep this one just in case. Just go them all. Okay, so now I'm going to restart my timer because I think I know what the bug is. And let me actually just get my, let me get this out where I can see it. And I don't need this at all. Don't know why that's there. Okay, so I'm going to resume my timer. I'm actually going to open a Diet Coke first. Product placement. Although it should be Pepsi, I suppose, if it's product placement. All right, let's get started. I'm going to make this a bit smaller. Okay. Resume timer. Okay. Okay, so the first one is diag neighbor is the add C of, well, the box itself, the neighbor face, plus so it's basically neighbor coord and the face itself. Great. Okay. Is occupied diag neighbor, in which case we should get the diag neighbor okay, and we should touched, and we should get you would need to extract this. Okay, where was I? Yeah. So the diagonal face will be the the neighbor, face neighbor. Oh my gosh. I really should have found a way to visualize this. Big lesson learned there. Actually, I don't need to do that yet. If diag face not in diag neighbor box faces touched, then Q append. Okay, diag neighbor box and diag face. Okay. Right, we going diag and going diag, going across, going down. Yeah, let's have that. Okay, 58. Is that the right answer? 58 is the right answer. Okay, very nice. That went remarkably well. Let's just try it with the input data. Why not? 2042. Okay, well, let's try that out. Oh gosh, sorry. 2042. Ah, amazing. Okay, well, that went surprisingly well. Really wish I had a visualizer on that. Might spend a little bit of time kind of working on 3D visualization in some way, because it's just horrible doing that stuff without a bit of visualization. The tools that I had here really did help this time. So that's a gold on the second part, which is good. And I'll work out what it was in the first part. That's day, whatever day it was, 18. There it is.